What we need to do now is take a general look at what SES software can actually do. Let's start first of all by opening up SES. We go to the Open screen and we come up to the main menu. As you can see, the menu is divided into Wells, SES, which actually is where you do your work, Grids, which attaches to grids that can be exported out of subsurface software of the client, which we rarely, if ever, do, and the Utilities program. Let's start first of all with the Utilities program. Here is where we can create or change an SES database. SES uses Microsoft Access to store all the data. Therefore, you must have Microsoft Access loaded. As I have said previously, you have to have Microsoft Access, you have to have Microsoft Outlook, and you have to have Microsoft Excel. I suggest using the 2010 version of these, mainly for compatibility purposes. But here you can change your SES database to anything on your computer that you wish. But right now I have mine set to September of 2012, actually over here on my E drive. So that's where my default is. We have the network settings, if you're actually on a network, which of course that we're not. The WITS-ML server. We can actually receive WITS-ML data in real time from the rig. And this would allow us to be able to do real-time geosteering no matter where we are, and assuming that they have access to a WITS-ML server on their location. Updates is right here, where we can check for updates of the software to be sure that we have the most current version of the software. And last but not least is where we actually import the license for SES. The Wells screen is where we maintain and create wells. We can add a well, we can delete a well, and we can edit a well from within this screen. Basically, all you need to do to create a well is just simply hit the Add button. And then we'll type in the name of the well, and that's basically all you really have to have inside of SES. In a later version of this training, we will actually go through and do all of these, but right now I just want to make you aware of what's available. On this screen also we can export a database that will allow anybody to load in this. It's called an XML file. The XML file maintains all of the data that's been worked on in a previous session and can be then uploaded by another user into his version of SES, allowing him to pick up right from where you left off. And here is the import button that allows you to import that XML file into your particular version of SES and allowing you to work onward. Record accounts, it's just simply recording the number of accounts actually in the database, was something that we never use. Now let's go look at SES itself. We click here and we see the various tabs come up. It takes a moment to load because it's going out and accessing the well information actually within the database of Microsoft Access. This is the main screen that comes up. This is where we input the survey data as it comes from the well. We'll input the measured depth, the inclination, and the azimuth, hit calculate, and then it will calculate the vertical section, and it will calculate the northing and the easting. As you can see, this particular well has a lot of gyrations. Now, we can also see in a three-dimensional format what this well looks like. We'll click right here, and here we have the rendering of this 3D well. As you can see, it's pretty much a mess, but that's what the drilling engineers designed, and we simply follow whatever drilling plan that they have come up with. But this is a three-dimensional rendering of the well. The type log is where we maintain the offset LAS file for the well. This is one of the very first things you will do when you are setting up a well, is import this type log. As soon as you hit this import button up here and select that your LAS file, and after it loads, it'll immediately ask you for this number. What is the top of the pay zone? That's when you have to go back to your GeoProg and see what the actual top is for the target. Because what it will have to do, it has to make the calculations of relative stratigraphic depth for all the footage based on that 0, which actually is the pay zone top. Everything in SES works off of relative stratigraphic depth. Therefore, we have to know what this target depth is in this offset well. This is the very foundation of how SES works. The LWD data is loaded in right here. This is where we would put in our gamma ray. Again, it's simply read directly from an LAS file and imported directly into the software. It then interpolates every single foot of that gamma ray against the survey information that we just imported. We can also put in rate of penetration, gas, or any other kind of LWD curves you want to add. They have resistivity, if they have neutron, they can all be added in right here. The planner screen is here, where we are provided the information necessary to create the well plan, and this will actually calculate and display our theoretical well plan. We don't have to have this information, but it's nice for us to be able to show this on our cross-section, which I'll show you in a minute. The next is the Geosteer screen. We have basic information about how the Geosteer screen is set up. Then we can go into our param tuner, and here we actually make the correlations and define exactly where the well bore is. We have discussed previously about shrinking and stretching data. This is simply how simple it really is to shrink and stretch data, and how to make sure that correlation lines up right where you want it to be. Now, while I'm going to do this again, I want you to watch what this dip number does up here. I'm going to move the gamma ray up, and notice the dip change is dramatic. And I bring it back down, it's equally dramatic. This is how we know what the bed dip is, because it's actually calculating based on the relative stratigraphic depth and the vertical section of the well. It's taking the arctangent of those values and then calculating what the degree and dip actually is of the bed. And you can see it in real time here. Watch this bed over here. There's the well bore coming into the bed zone. Watch what happens now as I change that bed dip, or change the shrinking and expanding of the data. Notice how the bed dip changes and moves around. This is how we determine what the bed dip is. As I've said many times, it's all based on that correlation, this correlation that we do right here. There are many numbers up here. We have the dip azimuth, which is telling you what direction, whether we're dipping to the north or to the south. And it also gives you the apparent bed dip and apparent inclination. This is the information right here for drilling inclination. So at 0.45 degrees, the bed is dipping in a northerly direction, so it's subtracting the inclination from 90 and giving you 89.55 degrees as the drilling inclination. It also gives the apparent bed dip here as well, which is negative, which simply means, of course, that it's dipping down, therefore it's negative to the north. That's briefly the param tuner screen. And last but not least is the cross section, and here is where we actually provide the cross section for the client, the thing that they'll probably use more than anything else because it'll be used in their presentations. Here is where we actually produce the cross section. You can see the well bore, you can see the various beds that they're drilling through, you can see what the target zone looks like, and we can expand this in any way that we wish. Right now it's kind of zoomed out, but we'll be able to actually zoom in at a later time. All of our LWD data that we wish to display can be shown. Up here we have the gas and we have the gamma ray and the ROP displayed down here, which is what we normally get a chance to produce. That's pretty much the information that we use on this on SES. We can go into THD technology. THD is total hole deviation. Again, this entire software package was written by a PhD petroleum engineer, and therefore his main interest in all of this was the engineering side. But that's not something that we do. It's not something that we're paid to do. So we really don't mess with it very much at all. We stay in the survey screen, the type log, the LWD, the Geosteer, and the cross section. Those are the tabs that we used far more than anything else. Well, that gives you a brief overview of SES. We'll go into each one specifically, each one of these pages specifically in the next series of webcasts, and see if we can't get you to the point to where you're beginning to really understand how SES works.